No. All right, so when we add and subtract rationals, we need a common denominator, okay? When we had monomials, we would just multiply by what was missing in the number in the variable, and then we put our denominators together. When we had not both monomials, so if we had a monomial and a binomial, or we had a binomial and a binomial, we multiplied them by each other and did not put the denominators together, correct? But we did put our tops together. So we only put the denominators together when it's a monomial. So this one yesterday, you would have multiplied this one by x plus 1, and this one by x plus 1, and this one by x minus 5, and this one by x minus 5. So we're going to get 2x plus 1. I'm just going to rewrite it so we can actually visualize it. X minus 5 equals on the outside. X plus 1 minus x minus 4 over x plus 1, x minus 5, x minus 5. Okay, so do we distribute our denominators ever, unless it's a monomial? No. So when adding and subtracting, unless both of the denominators don't have any addition or subtractions, we don't put them together. So we distribute the tops but not the bottoms. So on the bottom we're going to get x minus 5 times x plus 1. On the top we have to FOIL it, because when it's a binomial times a binomial, we do first, outer, inner, last. So we're going to go 2x times x, which is 2x squared. Then we do 2x times 1, which is 2x. Then we do 1 times x, which is 1x. And then 1 times 1, which is 1. Minus, rewrite my denominator. And then I have a binomial times a binomial, so I do my numerator. X times x is x squared. X times negative 5 is negative 5x. Negative 4 times x is negative 4x. Negative 4 times negative 5 is 20. So all I did was distribute the tops. We agree? Then we would rewrite our denominator, because they are the same answer. Even if they're out of order, it's multiplication, so they can be. X minus 5, x plus 1. And then we rewrite our top, 2x squared plus 2x plus 1x plus 1. And then we have to remember to change all the signs. So I'm going to get negative x squared plus 5x plus 4x minus 20. And then we have to collect like terms. So we get 2x squared minus x squared equals x squared. Plus 2x plus x is 3x, plus 5x is 8x, plus 4x is 12x. And then plus 1 minus 20 is negative 19 over x minus 5x plus 1. I can't factor the top because the only factors of 19 are 1 and 19, so it's not going to give me 12. But I do have to still state my NPVs, which are x cannot equal
Negative
5 and negative 1. Yeah, negative 1 and 5. Okay, so those are the ones we went over yesterday, where we didn't have common denominators, and they weren't monomials, but we had to multiply them by each other. We agree? So this is the last thing we're going to do with addition and subtraction. So what we've done is we had both monomials, and then we had to make them the same, correct? Then we had a monomial, binomial, multiply them by each other. Then we had a binomial and binomial that we couldn't simplify and multiply them by each other. There are way too many phones out for a new lesson. Then if I look at h on the bottom of it, I have p squared minus 1 and a p plus 1. So it's a binomial times a binomial. So what people will do often is they'll go to the test and they'll write p plus 1 on the left and they'll put p squared minus 1 on the right, because we're just so used to multiplying them by each other. But what is p squared minus 1? Yeah.
P plus 1.
P plus 1, P minus 1. So that's what we're actually going to do first. These are the advanced ones. So you have to spot that there's actually a difference of squares there. And then they're actually very close to the exact same denominators. They both carry one of the same factors completely. Both of them have a P plus 1. So how can I make them actually have the same denominator?
P minus 1 on the right side.
Yeah, P minus 1 on the right side. So I'm going to get 4 over P plus 1, P minus 1, plus, and I distribute the top, 2p minus 2, but I do not distribute the bottom because it's not a monomial and a monomial, right? That's the only time I distribute them. And then I can rewrite it as p plus 1 over p minus 1. And I get 4 plus 2p minus 2. And then I collect like terms. So I'm going to get 2p minus 2 plus 4 plus 2 over p plus 1, p minus 1. So we've done all of the addition and subtraction work, correct? We've done all the addition and subtraction work. We got a common denominator. We distributed the tops. We collected like terms. Once we're done the whole addition and subtraction part, what did I tell you is the very last step you have to remember to check for? You have to make sure you do your NPVs and check if you can simplify, GCF in this case. So the very last step of an addition and subtraction should be, can I make it simpler? Can I do simplification like the very first lesson we did in rationals? So what can I do to the top here? I can take out a 2. Then I'm left with p plus 1. Now before we go canceling off those p plus 1s, what do I have to do? NPVs, because I always have to state NPVs before I cancel, right? Always, always, always. If you're stating them after you cancel, you're going to pick the wrong answer on the diploma and on the unit test all the time. P plus 1's cancel, and I'm left with 2 over p minus 1. But I have to make sure I say x. There's no x's in here. Come on, Lepp, grab a minute. P cannot equal plus or minus 1. Because even though the positive p plus 1 canceled, I still have p can't equal negative 1 because at one point it couldn't. Okay? So we don't immediately just go multiply both denominators by each other. We first have to check and see, can I reduce my denominators to maybe make them the same? Yeah. Yeah. So we're going to look at I. Is there anything I can do to I? What? Take a 5 out of the left denominator and do what to the right one? Take a 2 out. So I'm going to get 4 over 5 x plus 1 plus 3 over 2 x plus 1. Now they have an x plus 1 in common, correct? How can I make them the same? Yeah.
By the right by 5, the left by 2.
Yeah, so we're going to multiply the left by 2, and we're going to multiply the right by 5, so that we have 10 x plus 1. And we can put the 5 and the 2 together because they're monomials. So we're going to multiply this one by 2. We're going to multiply this one by 5. So we're going to get 8 over 10 x plus 1 plus 15. Yep.
Why don't you just times that 2 by 3? Like, just times the right side by 3, so then you go 5 x plus 1.
What's 2 times 3?
Oh, yeah, true. Never mind.
So now we can get a common denominator of 10 x plus 1. And then we're going to go 8 plus 15. You just made a silly error. Not a big deal. 8 plus 15 is 23 over 10 x plus 1. Can anything cancel? No. If it was a 24 instead, could stuff cancel? Yeah, and then I could take a 2 out. Because it's like this, I can't. And I have to make sure I go x cannot equal negative 1. You're going to try this one. J. Okay, what's the first step I have to do in J? What's the first step I have to do? Yeah.
Take out an x in the denominator.
Take an x out. So this one stays the same. And this one I get an x and an x plus 2. Now on the right I have an x and an x plus 2. If you're on your phone, you should not be. On the right I have an x and an x plus 2. On the left I have just an x. What do I need to multiply the left by? And what do? Do I distribute the denominators or not? Denominators. Yeah, those things. The denominators? No, because they're not monomials, right? Only when it's like 2x times 3x or 7x times 4x, when they both don't have, both denominators that you're multiplying by don't have a plus or minus sign, you put them together. Other than that, if there's a plus or minus sign in either of the factors in the denominator, they stay apart. You don't put them together. So this one has an x, but this one has an x plus 2, so I'm not putting those back together. I'm going to leave them separate. So this left side I'm going to multiply by x plus 2. And 1 times x plus 2 is x plus 2 over x plus 2. Minus 1 over x plus 2. And I have a common denominator of x plus 2. And in the top I have x plus 2 minus 1. Collect like terms. I get x plus 1 over x plus 2. So once I've collected my like terms, my last step I always do in addition and subtraction is I say, can I simplify? Is there anything I can simplify in there? No, I can't take out any GCFs. I can't do any crossing off. I'm stuck. So that means I'm done, except I have to do what? State NPVs or restrictions. They're called non-permissible values or restrictions. So we're going to say x cannot equal 0 or negative 2. This one. They look the same, the denominators, but they're opposite signs. So I have positive x minus 1, and I have positive 1 minus x. What did I tell you to do when we went to try and cancel them off? We went to go cancel them if they were opposite signs. What did I tell you to do? What did you have to take out? A negative 1. So when you had two factors that were the exact same, one on the top and one on the bottom when we were doing simplifying, and they matched but they were the wrong sign, if we took a negative 1 out, they would completely match, we could cancel them. We only took a negative 1 out of one of them, correct? Same thing here. We want these to match, we're going to take a negative 1 out of one of them, not both, or we're just counterproductively changing both of them. So I'm going to take it out of this one because I don't like the order of them. So I'm going to go equals 2 over x minus 1. So this is a positive x minus 1, this is a positive 1 and a negative x. So I'm going to take a negative 1 out, and then I'm going to be left with negative 1 plus x, which is actually the same. I know they're out of order, but they're the same, right? Now the cool thing about the negative 1 is you can just bring it to the top and distribute it, or you can leave it where it is. Most you're going to leave it where it is. So we're going to have to multiply the left side by negative 1. So we have a binomial in our denominator. So are we going to put anything together if we have a binomial there? No. The moment we have something in a denominator with a plus or minus sign, we're not going to put it together. So the top we will. We're going to get negative 2 over negative 1 x minus 1 minus 1 over negative 1 x minus 1. So then we have negative 1 over x minus 1. And we'd had negative 2 minus 1, which is negative 3. Now they may give the answer like this, but you have to be prepared for this one extra step, okay? So pay attention. So the answer can be given like this, or, I hope I didn't unhook that, nope. Or they could take this negative 1 and bring it up and put it into the top. So this could be an answer, or they can bring the negative 1 up and multiply it by the numerator. Because that negative 1 can move to the top or the bottom, which would actually make it be 3 over x minus 1. So this, or this could be my multiple choice answers. People will say, well, what if they give me all three? They can't. They're all right. They can only give you one of them. But they could give you this one, and if you don't know that negative 1, it's only if it's a negative 1. If it's a number or anything else, it just stays. You can't do anything with it. A negative 1, remember this, if I gave you negative 1/3 in grade, I think they started talking about this in junior high. So if they gave you negative 1/3, they said you could also write it as negative 1/3, or you could also write it as 1 over negative 3, like that negative 1 sign can move. It's the same thing. It's only because it's a negative 1. If it's any other thing, I can't move it. So negative 1, I can bring it to the top and make it join the negative 3, make it be a positive. Okay, I just want you to know that because I don't know which answer they're going to give, and they could give any of them. And then we're going to follow behind with x cannot equal 1. So if we look at L, we have 5m plus 1 over m minus 7, positive m minus 7, plus 4m plus 8 over m, positive 7, negative m. So what do the both denominators actually have in common? They both have an m in common. And then their other factor is actually the same, but what? Different sign. So instead of them taking an m out, what should they have taken out? A negative m, which would have changed this to a negative 7, would have changed that to a positive m, and now they would match. That's it. They should have taken a negative m out. Yeah, shameful. So, what do I need to do to make these match? Multiply the left side by negative 1, right? Because now the m matches, this matches, but I need a negative 1m, correct? So I'm going to need to multiply that side by negative 1. Now this is the catch too. When I multiply the bottom by negative 1, I'm just going to get negative m minus 7. But what do I have to watch that I do to the top? Make sure that negative goes to the 5m and to the 1, right? Because I'm multiplying the whole numerator by negative 1, not just the 5. Do you think they'll have the answer to you multiplying just the 5 by it there? Yeah, it's going to be common error, forgetting to distribute it through. So we're going to get negative 5m minus 1 plus 4m plus 8 over negative m minus 7. Now I have common denominators. So I can go negative m minus 7. And on the top I get negative 5m minus 1 plus 4m plus 8. Then I'm going to collect like terms. Negative 5m plus 4m is negative m. Negative 1 plus 8, positive 7. And then what's my NPDs? M cannot equal 7. Most people get that one right. What if it's a negative m? If it was an m, we just say it can't equal 0, right? Does a negative m change that? No. It's the same thing. It can't equal 0.